Yes, fine, dear students. Today we are going to discuss about the waves chapter here. So, what we are going to discuss here? Waves chapter. So, in waves chapter, first, what we are going to discuss here means we are going to discuss about the progressive wave. We are going to discuss progressive wave. What is meant by progressive wave? What are the properties of progressive waves? We are going to discuss here. Fine. What is meant by progressive wave means a wave which travels continuously in a medium. A wave which travels continuously in a medium with constant amplitude and frequency is called progressive wave. Progressive wave, which we can call it as. So that wave, what all the things should be constant means amplitude should not change here. After that, what should be same? Frequency should be same. So those type of waves is called what? Progressive wave, which we can tell here. We need to mention here what? Equation of progressive wave we need to mention here. So let me mention equation of progressive wave. Equation of progressive wave. See, equation of progressive wave means what we need to mention means a wave which travels continuously in medium with constant amplitude is called this velocity different, right? So we need to let me discuss one example here. That velocity, frequency, wavelength is all things we already discussed here in oscillations chapter. Let me explain once again. I'm taking one wave like this. Like this. If I observe here now, this amplitude, if I check now, it should be constant here. Okay. So this is called amplitude now, basically. The maximum displacement is called displacement of wave is called amplitude, and this is called time period. So time period and amplitude will not change. Amplitude and time period, because frequency is same, no? So time period also should not change here. So velocity of wave, if you want to discuss here, no? Velocity of wave. You know the general displacement formula. Velocity is nothing but displacement by time or distance by time speed. So time equal to what we can write here? Time can be written as distance by speed. You can write it. So time can be written as what here? D. What we can take here? This from here to here, it is called wavelength. Na? This can be taken as lambda. So lambda by v we can write it here. Therefore, T equal to what we can write it here? Lambda by v, and lambda by v. Okay, fine. Write regular formula. V equal to d by t. V equal to, in the place of d, what we substitute lambda. One lambda by t can be written as f. So v equal to lambda f, or c equal to lambda f, and c equal to lambda mu also sometimes we can write. This is called what we can tell here means velocity for wave or speed of the wave, which we can tell here. C equal to lambda f, where lambda is wavelength and f is nothing but frequency. C equal to lambda mu, mu also we can indicate as a frequency only, frequency symbol. And this is what? Wavelength. C is nothing but speed of the wave, which we can discuss here. Now, what we are going to discuss here means your general equation of wave we are going to discuss here. General equation of wave. So, what is the general equation of wave means? We know that SHM equation, right? What we know SHM equation? Y equal to A sine omega t. Along with that phase, what we get it means here, we'll get like minus kx will get here. Here, you know that omega is now already, you know that angular frequency 2 pi by t, and k can be written as what here means k equal to what we can write 2 pi by lambda, which relates with the wavelength, and this is also called what we can tell here wave number, which we can call it as wave number. So y equal to a sin omega t minus kx, we got it. So this we can alter also. Y equal to a sin, in the place of omega I can substitute 2 pi by t, 2 pi by capital T into t minus 2 pi by lambda into x. So what we can take common, we can take 2 pi also common. Therefore y equal to a sin, if I take 2 pi common, no, t by t minus x by lambda will get it. This is another form of the general equation of wave, which we can tell here. Now I would like to take from this equation directly omega, I would like to take outside. If I take omega outside, what will happen? Let me check. Y equal to a sin, if I take omega outside, in this term what remains? Only t remains, t minus kx by omega, which will get it here for this equation. Kx by omega, which we can write it here. Next, I want to check the ratio of omega by k. Ratio of omega by k I would like to discuss. What is omega value? 2 pi by t we know. K value is how much? 2 pi by lambda. So 2 pi by lambda means I can write like this, lambda by 2 pi will get it here. This fellow will get cancelled. That equal to what we got it? Lambda by t. Lambda by t, 1 by t can be written as what? Frequency. Lambda f, we got it. So lambda into f is nothing but what? Speed, which we can write it here, c. Therefore what we can write it here means the ratio of, otherwise I can tell like this, therefore the coefficient of t divided by coefficient of x is equal to what we can write it? C we can write. Observe here, coefficient of t is what? Omega. Coefficient of x is nothing but k. We'll use the C, we can write it. Therefore omega by k equal to what we can write it? C we can write it. Or omega by k also can be written as what? C value is nothing but f lambda. F lambda also you can write it here. So from here k can be written as what here? Omega can be written as 2 pi f. So 2 pi f by k equal to f lambda, we can write it. So ff can get cancelled here. So what will get here? 2 pi by k equal to lambda also we can write it. So k equal to what will get it here? 2 pi by lambda. This is how we got k value. Okay. And from here 2 pi f by k equal to what we can write it? C. Therefore 2 pi f by c equal to what we can write it? K. So this k value we can write in terms of speed of wave and f also. F by c also we can write where f is nothing but frequency. So what is the general equation we are having? Y equal to a sin omega t minus kx. Omega is called angular frequency, 2 pi by t. K equal to what we know? 2 pi by lambda. That's nothing but wave number, which we know. Y equal to a sin omega t. In the place of omega, what we are substituting here? 2 pi by t we are substituting into t minus 2 pi by lambda into x we are substituting. So in this term 2 pi comes outside, means what remains? T by t minus x by lambda. I would like to change this formula into other form. If I take omega here, what will come? Here we need to multiply with omega, divide with omega. So omega kx divided by omega will get, na? See, if we take outside omega, no, t minus kx by omega also will get it here. So this is another form of the SHM equation. Or we are discussing about the waves, no? Wave equation, which we can discuss. SHM equation means up to only omega t, you can discuss here. Fine. Next, if you observe, no, the ratio of omega by k we are checking 2 pi by t omega value and 2 pi by lambda is k value, no? So if we reciprocate, no, lambda by 2 pi. 2 pi will get cancelled. So C equal to lambda by t or lambda f, we got it. Therefore C equal to lambda f, we got it. So that's nothing but C value, which you already derived, right? So that's why omega by k equal to what we can write? C. That's why we mentioned clearly here, the coefficient of t to the coefficient of x ratio will give you what? C value. So this is an important formula to solve the numericals, so which we derived here. All basics we are going to derive here. Omega by k equal to C, we got it here. Omega by k equal to, you know, that f by f lambda. 2 pi f by k equal to f lambda. 2 pi by k equal to what we got it? Lambda. So we can derive k value also, wave number value. Or 2 pi f omega by k, na? Omega can be written as 2 pi by t. So omega equal to 2 pi by t. 1 by t can be written as what, na? Frequency. 2 pi f, which we can write here. That's why 2 pi f by k equal to C, we can write it. 2 pi f by c equal to what? If I switch this both here, no, 2 pi f by c equal to k, we can write it. This is also one of the important formula to solve the numericals, which we need to observe here. See, in this slide, what we are going to discuss means we are going to discuss about the direction of the wave. Direction of wave. So what we know general equation of wave? We know general equation of wave equal to y equal to a sine omega t minus kx, general equation which is given here. So what is the direction of the wave? Which direction wave is traveling? We need to tell me. First you need to know about the, so first coordinate of x, coordinate of t, let me choose first, then coordinate of x, next direction of the wave we need to know. If you observe here clearly, coordinate of x, t means this is positive or negative, I'm asking. X means this is k value positive or negative, I'm asking. So first I'm giving one rule here. If omega value is positive, if k value is positive, what will happen means wave will travel about negative direction. If this is negative, this is negative, what will happen means still wave travel about the negative direction. If this is positive, this is negative, means t coefficient means omega value is positive and k value is negative, then it travel about the positive x direction. For example, this is negative and this is positive, then this will travel about the positive direction. So what we understood here means we need to tell that if among those both coordinates, in any one coordinate should be positive, one should be negative, then wave will be traveling about which direction? Positive x direction. If both are same, no, it will travel about which direction? We can tell here negative direction, you can observe. So for this case, what we take an example, this case omega t, omega value is positive minus kx, k value is nothing but negative here. So wave will travel about which direction? Check. Omega value positive and k value negative, wave will travel about positive x direction, positive direction. Therefore let me write one more equation here. Y equal to, we are writing like a sine omega t plus kx, I'm writing here. If you observe omega value, how much is there? Positive. K value also how much is there? Positive. Positive means wave will be traveling about which direction? Negative direction, we can tell here. For example, I'm writing one more equation here. So let me choose another equation. Y equal to a sine kx minus omega t. So here k value is how much? Nana? Positive. Omega value is how much? Negative. Omega is negative, k value is positive. Still it travel about which direction? Positive direction, we can write it here. So both also negative, we can write sometimes. Y equal to a sine minus kx minus omega t, we can write. Both are minus. K value also minus, omega value also minus. If both are negative also, what we can tell? Wave is traveling about negative direction. This is how we have to decide how wave is traveling, about which direction, positive direction or negative direction wave is traveling, we need to understand here. In this slide, we are going to discuss about the transverse wave and longitudinal wave. So what is meant by transverse wave? What is meant by longitudinal wave? We are going to discuss in this slide. So what we are going to discuss? Transverse wave, and another one is what here? Let me divide into section. Another one we need to discuss about longitudinal wave. Longitudinal wave. See, what is meant by transverse wave? Transverse wave means what means? The particles of a medium vibrates perpendicular to the direction of the wave propagation. The particles of a medium vibrates perpendicular to the direction of wave propagation. Direction of wave propagation. Example, what we can give means here. Example is nothing but vibrations in a stretched string. Vibrations in a stretched string. How will get vibrations in a stretched string means? Let me explain more point here. So they travel in the form of crest and thrust, Nana. They travel in the form of crest and trough. Fine. For example, if I take stretched string here like this, if I make waves passing, if I give small pulse to that, what will happen? We'll get wave like this. So this indicates what here? Crest, right? And this indicates what here? Trough. This will travel in the form of this. And what is meant by longitudinal wave, which we have to know here means longitudinal wave is nothing but particles vibrates in medium in the same direction of wave propagation. Here, in this case, if you observe, no, wave is traveling in this direction, particles are vibrating in this direction. In this case, what will happen? Let me check. Longitudinal wave. Longitudinal wave means what? The particles of the medium vibrate in the same direction of wave propagation. Example, propagation of sound wave in wave. Propagation of sound waves in air. So how does they travel means? They travel like this, Nana. They travel in the form of compressions and rarefactions. How we can call it as crest and trough? No, here we need to call it as what? Compressions and rarefactions. How we'll get wave? How we can observe in sound means? So you can get like this, Nana. Like this, some patterns we can observe. See, some patterns are very closer here, like this. Some patterns are wider. These closer patterns is called what we can call it as means compressions, which we can call it as compressions. And wider patterns is called what we can call it as means rarefactions. Rarefactions, which we can call it as. But if you observe here, no, transverse wave, they can set up only in solids here. They can set up only in solids. Here, these can set up solids, liquid, gases. They can set up solids, liquids, and gases. Everywhere this can set up. This is a very important point. This can set up solids to liquids to gases. Everywhere it can set up, but these can be set up only in solids, which waves transverse wave. Longitudinal waves can set up everywhere. Solids to liquids to gases in all the cases which can set up. Fine, in this slide, what we are going to discuss means here we are going to discuss about the speed of the transverse wave, which we are going to discuss here. Transverse wave speed. Speed of transverse wave, which we need to discuss here. See, how they're telling means, see in NCET itself, they given in terms of dimensional formula. They're telling velocity or speed, velocity of transverse wave is dependent on, first point what they're telling means, tension in the string, or material. Second one, linear mass density. Linear mass density that they are giving like mu here. So what they're telling here means velocity is directly proportional to what here? Tension. And another one, what they're telling? Mu. I don't know powers. That's why I'm taking this power A, this power B I'm taking here. So we discussed in Newton's laws of motion, tension is nothing but one force. SN, it also I told you Newton. That's why so let me make this as equation number 1. Now, velocity dimensional formula, you know what is the velocity dimensional formula? M power 0, L power 1, T power minus 1, you know. And T dimensional formula, T for tension. Tension is nothing but force na here. So T equal to, you can write it. Dimensional formula is how much? M power 1, L power 1, T power minus 2, power A. And mu is nothing but what? Linear mass density. Linear mass density means mass by length. Mass by L length means M by L. L means L power minus 1 will come to numerator. And this is power B. You just send powers inside, Nana. So what we can do here? M power 0, L power 1, T power minus 1. That equal to M power A we are having. Here what we are having? M power B. If I write here, no? M power A plus B. And if you observe here, no? L power A, L power minus B we are having. So what we can write it here? L power A minus B. If you observe T, no? T power minus 2A we are having. T power minus 2A, which we are having here. Therefore, if you observe here, no? This A plus B should be equal to 0. A plus B is equal to 0 because MLT, bases are equal means power should be equal. A plus B equal to 0, we can write it. Therefore, A equal to what we can write it? Minus B, we can write it here. Now, if you observe this fellow, minus 2A equal to minus 1. Minus 2A equal to minus 1. Minus will get cancelled. Therefore, A equal to 1 by 2. If A equal to 1 by 2, what it means? B value is how much? A equal to minus B, right? So, B equal to what will get it here? B equal to minus 1 by 2, which we got it. So, these values which we are taking here, and A value and B value, we are substituting in this equation 1. So, on substituting equation 1, what will get it here? V is directly proportional to T power A. A value is how much? 1 by 2 and mu power B minus 1 by 2. So, V is directly proportional to T by mu whole power 1 by 2, we can write it here. Because if it goes to negative to denominator, no, it will become positive. Therefore, V equal to K times E under root T by mu, I can write it. 1 by 2 value, we can write like a root. So, the K values in SN, it's nothing but how much they given means 1. Therefore, velocity of the transverse wave, what we got it means V equal to root over T by mu, which we got it here. Now, we need to discuss about the what means. We need to discuss about the longitudinal wave, which we need to discuss here. Longitudinal wave. Longitudinal wave speed or velocity, which we are going to discuss here. So in this topic, I'm not going to derive. So you people have to derive by following same method. I'm going to give directly answer here. So what is you will get means V equal to under root of E by rho, you will get it here. Where E is nothing but what? Modulus of elasticity. Modulus of elasticity, which we studied in mechanical properties. And rho is nothing but what you can tell here, density of medium, in which medium it is moving. Density of medium. See, depends, Nana, it depends. This will be having many types, right? If it is solids, Young's modulus, if it is fluids, bulk modulus, these all things we're having, right? So let me check here. For example, if it is solids, solids. So that E will become like what? Young's modulus. Therefore, V can be written as what here? Under root Y by rho. So direct formula based question they asked here for JEE 18 they asked here. Right formula based question. Speed of the sound wave in so and so solid whose Young's modulus is so much they given here. And for fluids, how to write for fluids? E will become as what? Bulk modulus B. Therefore, V equal to what we can write here? Under root B by rho, which we'll get it here. This formula we are going to use where? We are going to use in speed of the sound wave in air. We are going to derive now. So this only we are going to use here. Air is nothing but fluids, no? So that's we are going to use same formula here. And we are going to apply that this thing we studied, adiabatic values, isothermal values in thermodynamics. We are going to substitute that values here. So speed of the transverse wave just by using dimensional formulas we derived. So longitudinal wave also we need to derive in that only. So how to mention it? So velocity of this longitudinal wave depends on here tension we written, here we need to write modulus of velocity. Second one, linear mass density, I told you, density of the medium, just take and apply dimensions, we get the same answer. What will get it? E by rho. For solids, Y by rho. For fluids, what will get it? V by rho. And this value also you have to remember, V equal under root T by mu for what? Transverse wave, which we need to understand here. Fine. In this slide, what we are going to discuss means we are going to discuss about the speed of the sound wave. We are going to discuss here. We are going to discuss about speed of sound wave. Speed of sound waves, which we are going to discuss here. In speed of sound waves, what we are going to discuss here means first we are going to discuss about the Newton's formula. Next, we need to discuss about the Laplace correction. So first, what we are going to discuss? Newton's formula. Newton's formula. So what does Newton assumed and what all the things he got wrong? And after that, who came to correct that? How much what he corrected, we need to discuss here. Fine. Let me discuss about the Newton first. What is Newton telling means? Newton assumed that when sound waves travels in air, temperature remains constant. He told temperature remains constant means which process it is? Isothermal process he assumed. Isothermal process. In isothermal process, we know that by isothermal bulk modulus B iso equal to what we given here? We given like P we given here. This is nothing but which we learned in thermodynamics. So you know that velocity of the longitudinal wave, V equal to under root E by rho. Here we are discussing about the air, you will get under root B by rho. How much is that B value? P, pressure by rho. So your atmospheric pressure we need to go substitute here. What is the P value here? Having P equal to 1.013 into 10 raised to 5 pascals, And density of the air, that. Density of the air is nothing but what we know here. 1.3 kg per meter cube, which we know. We are going to substitute these values. If you take here now, where is this? V equal to under root P by rho. 1.013 into 10 raised to 5 divided by 1.3. So if you substitute, if you calculate now, this value will come out to be 280 meters per second, which will get it here. But if you observe here, but experimentally this value is wrong here. But experimentally, how much they got it means 330 meters per second. So if you observe, no huge difference is here. That's why what they did means, so this theory was discarded, cancelled, not taken in consideration. This theory was was discarded. Then what will happen means, then who will come into picture means Laplace will come into picture. Newton's assistant Laplace is Laplace correction. In Laplace correction, what is going to assume means Laplace is going to assume changes in atmosphere is adiabatic. Okay, he assumed that propagation of sound waves in air is have adiabatic changes. Adiabatic changes in where? Adiabatic changes in air. That's nothing but atmosphere he is telling. Now what we can mention means here, you know that adiabatic bulk modulus, what is that? B adiabatic. B adiabatic equal to gamma P, you know. So in the place of B, what we are going to substitute here? V equal to under root gamma P by rho, which we are going to substitute here. This already we discussed it 2 times. So gamma P by rho we are having no substitute values here. So under root gamma value how much I'm taking means I'm taking here 1.4. Why? I'll explain you. P value how much? Just now I given 1.013 into 10 raised to 5 divided by 1.3. So after calculation, this value comes around to be what, Nana? 330 meter per second. Now I need to tell you why I need to take gamma value as 1.4 here. In atmosphere, most of the molecules is having which nature, Nana? N2 na? 1.4 I'm taking. N2 and oxygen only is there in atmosphere, most of the value. That is diatomic. For diatomic gamma value, how much will get it? 1.4, which we already earlier discussed in 2 places. One is thermodynamics, another is nothing but kinetic theory of gases. So those gamma value only I'm going to use here. If I calculate it now, how much you got that value? The value comes out to be V equal to 330 meters per second. So if you observe now, this value is almost matching with the sound of the wave. Okay, that's why you can tell here this is excellent agreement with experimental value. So that's why whose equation is considered means Laplace equation, assistant of who that fellow, assistance of Newton. That value is considered actually. Now speed of the sound waves we have to discuss Newton's formula. Newton said that what changes in atmosphere is nothing but isothermal. We just substituted B value here in the place of E, B, in the place of B, P. These values if you substitute, this value comes on to be 280 meters per second, which we got it here. But this value is not considerable because experimental value is around 330 meters per second. So that's why next we go on with Laplace, who is this fellow means Newton's assistant. He assumed that changes in the atmosphere is nothing but adiabatic. So B adia equal to gamma P, right? Gamma value I'm choosing 1 by 1.4. P value you know from here, and the density of the air also you know from here. You just substitute these. So V value comes around to be how much? 330 meter per second. So generally speed of the wave is nothing but speed of the sound wave in air is nothing but 333 experimentally, right? So this is excellent agreement with the experimental value. That's why we can conclude gamma P by rho is the final formula or the velocity or speed of the sound in air. Gamma value I'm choosing like 1.4 because in atmosphere almost all molecules having nitrogen and oxygen only, right? Diatomic molecules. That's why I'm taking gamma equal to 1.4, which we have discussed here. This is very important for as well as boards as well as competitive. Boards also they'll ask you, CBSE boards, state boards also they'll ask you. In this slide, we are going to discuss intensity of a progressive wave, which we are discussing. Very important for 11th and 12th. Please listen carefully. So what we are going to discuss here? Intensity of progressive wave we are going to discuss. So what is the intensity of progressive wave, which we need to discuss here? Fine. So what is the intensity of progressive means? Intensity definition, how can you write it means? Energy falling per second per second per unit area. The same thing you will get 2-3 times in 2-3 chapters in next year also. Okay, so intensity capital I can be written as what here? Energy falling per second. Energy by second is nothing but what we can write it? Power upon area, which we can write it area. Therefore energy can be written as what? Power can be written as what? Energy upon time. No, intensity equal to energy by time into area, which we can write it here. So energy of the SHM, you know already, which we did in last chapter, SHM equation, half omega square m into a square, which we know, not a square, half omega square m we know. So, and we need to do something here. What are the basics we need to do here? Means velocity is nothing but what we know, length upon time. So length can be written as what here? Velocity into time, which we can write it here. And you know that density equal to what we know here? Mass by volume, you know. So volume equal to what we can write? Mass by density. Volume can be written as what? Area into length equal to mass by rho, we can write it here. So if I send here, A equal to what we can write now? From here, A equal to m by rho L, m by rho L. And L equal to what we got it here? L equal to Vt, I got it. I'm just substituting that value also. A equal to m by rho into, in the place of L, what we're going to write? Vt, I'm going to write here. Okay. Now, amplitude square is there, right? Okay, amplitude square divided by what we are having? Time, Nana. Time, what we are having here? T only, into area. In the place of area, what I substituted? M by rho Vt, which we got it here. So m by rho Vt, which we got it here. Now, what are the things will get cancelled? Let me cancel here. So if you observe here, now this t will get cancelled. This mass will get cancelled. 1 by rho means this rho will go to numerator here. So how can you write it? This half, that equal to what we can write now? Intensity equal to what we can write it? Half into omega square rho v, which we got it here. Half into omega square rho v, which we got it now. You know that omega value, omega can be written as what here? Omega equal to 2 pi f, which we can write it. So just substitute that value in that. So I equal to what we can write means half into omega square. Omega square means what? Omega square is nothing but 4 pi square f, you got it. 4 pi square f square. Where are we missing? Something we're missing. Amplitude square we're missing, right? In this. Your amplitude square is there. Amplitude square. Okay, f square rho v amplitude square, which we got it here. If you observe now, this is 2 will get cancelled here. So I equal to, I'm rearranging terms, 2 pi square a square f square rho v. This is the final equation of intensity, which we got it here, which we need to remember for sure. Very important. Next year, 2-3 places we are going to use same formula here. 2-3 places means 2-3 chapters we are going to use. So to remember this, I'm going to give one short trick here. How to remember this formula? To remember this formula, I'm going to give one short trick here. You just remember like all friends rone wala. All friends rone wala. See here, A stands for what? Means amplitude. F stands for frequency. Rho stands for density. V stands for speed of the wave, which we can tell here. And this 2 pi square you can take as a constant. A square, F square is there. Next to rho V is there. Squares are not there. So you just remember this phrase to remember that. I equal to 2 pi square, A square, F square into rho V, which we can tell here. When the wave enters from one medium to another medium, what will happen means speed and lambda are changes, but frequency remains constant because frequency depends on the source, Nana. So who is emitting the sound, it depends. Okay, let me mention that note here. So note. So what is the notes we need to remember is here? When a wave enters from one medium to another medium, V and lambda are changes, but frequency remains constant. frequency remains constant, means frequency will not change because it depends on source now. Frequency is nothing but source property. Who's going to emit that property? Source is not changing, no, that's why. So what we can write means, that V equal to F lambda, here. V equal to F lambda, frequency is constant here. Therefore, V is directly proportional to lambda, we can write it here. Therefore, V2 by V1 can be written as what here? V2 by V1 equal to lambda 2 by lambda 1. This result also will be useful in many places to solve the numericals. V2 by same thing we're going to use in reoptics a number of times in next year. And we have to remember here, intensity and amplitude relation is what? Intensity is directly proportional to amplitude square, we can write it here. I is directly proportional to amplitude square, which we need to remember here for sure. This is also important relation. I is directly proportional to amplitude square. V2 by V1 equal to lambda 2 by lambda 1 when going to another medium. Intensity of equation 2 pi square A square F square rho V, we got it. I given one phrase to remember, all friends rho ne wala, which we can discuss here. This is the proof for that intensity. For both, sometimes they can ask you, but for sure you have to remember this formula for solving the numericals in second year wave optics also. A student, this is for today's class. Please go revise once again this concept. We did very clean theory and as well as what all the formulas required for competitive. We made the concept strong. Please go and revise once again. And thanks you for watching this lecture.